Welcome, guys. So number 40, and okay, be sure to subscribe to my channel. Okay, so number 40 said that there's a particle mass separate into mass part and no mass part. Okay, so suppose this momentum is p, this momentum is p. So basically, we just use the energy conservation. So we have mc squared equals to pc plus m squared c to the fourth p squared c squared. And in order to solve it very quickly, we can let c be equals to 1. Because when you see the choice, there's all of them contains 1c, so you don't need to worry about anything. Or worry about c because you know that it doesn't change your choice. So we change p to another size and then we square it, and we cancel it. So we get p equals to m squared minus small m squared over 2m. So the answer is B. The answer is B. Nice shot. So 41, basically this is the photoelectric, and you plot what? You plot the stopping potential versus frequency. This is also easy. This is also very easy because the stopping potential, basically this is the energy minus the work. Some constant work function is the stopping potential. So you plot what? You plot the starting potential versus the frequency. So the slope is h not h bar, h over e. So the answer is B. Answer is B. Oh shit! I cannot delete all of them. Okay, so 41, 42. Okay, so you have to sinusoidal waveform, and and the horizontal sweep is 100 nanoseconds per centimeters, and ask about the phase difference. Oh, difficult, right? Very difficult. So basically, you see, so if it's easy because this is multiple choice. This is a single choice, so it's not difficult because if we see that the peak corresponding to the bottom of another wave, then this is 180. If we see the peak corresponding to peak, which is 0 degree, so you see the peak is not directly mapped to so the answer should not be the answer is just between 0 and 180. Although it did not tell us anything, but we can see the peak to peak contains like the peak to peak contains like let me see, we can, so the peak is here, the peak is, so peak to peak contains like 2, let me see, 1 contains like a 2 centimeters, contains like 2 centimeters. So what tell you that so the difference is like 2 centimeters, and the total wavelength is like 6 centimeters. So 2 over 6 is 1/3. So times 2 pi. So the answer is 2 pi over 3. And which is E, right? 2 pi over 3. This is 180, so it's 120. So the answer is E. A 43 diamond structure. Oh, so you need to remember answer. Then you need to if you forget, we can plot the diamond structure here. Basically, I mean, don't have to plot, but you know that it's basically the tetrahedron. Okay, so the answer is D. The answer is D. BCS theory, you know that attraction of Cooper pair is due to the what? Not weak force, not strong force. We are not talking about high energy, not vacuum polarization. Basically, the due to lattice, right? Due to lattice, because lattice will couple two electrons, will somehow couple two electrons into one, forms a Cooper pair. So the answer is D. There are a hurricane and a 120 hertz whirring sirens on town halls on the Y is blowing 50 meters per second in direction from siren to other person 1 km away. Or for frequency. Okay, so this is the sound Doppler effect. Okay, so sound Doppler effect. Remember that the Doppler effect formula is the speed of sound plus the speed of source and speed of sound. Oh, not source. This is observer. Sorry, and this is source. Source times okay. Okay, and so now there's hurricane and the wine is exploding to our person. Okay, and then what's the sound wave is here. So there's a wine. Okay, but the problem is that there's no so basically the object does not move, and the source does not move, right? Because there's no because that sound is not coming from the that sound is not coming from the wind. So although it looks like there's a Doppler effect, but actually there's nothing there's nothing move, or if there's actually not something move, then both wine and both sound and human moves. So basically there's no special, so the observer and the source does not have any relative speed. So there's no Doppler effect. The answer is C. Okay, and 46. Basically, you know that each time you see the diffraction and the long rectangle or something, you know that basically asking about the very famous formula. It's the day sine theta. Let me find a clear place. Okay, so this 36. So you know the day sine theta is the lambda. So this is the standard. So in a Bragg diffraction refraction, you need there's m, but in this case we solve first lambda and see what's the result. So it has 350. Why 350 is speed, right? So the lambda we are asking about the frequency. So frequency equals to d. D is this one. This is D, right? Sine theta is 45. Okay, so we can solve V. And the frequency is this one, hertz. And luckily we have the answer here. We have the answer D here. So this is nothing special. Okay, then this is 47. Okay, so 47, this is old question. So let me remind you guys some formula you need to remember. Okay, so there's so one important property is that if there's a closed end, then frequency is mv over not v. Let me see, mv over 4l. M is 135. So this is the common formula. M is odd integer, and frequency has this form, and has the so open by close at 1 and then open at 1. Basically, this is the situation what we have. What's the next? So the next is the 1 to 3 to times 3. So the answer is D. The answer is D. By the way, you need to remember the formula. And I also remind you guys, if 2 and are open, then this is the answer. M is the 1, 2, 3. You need to remember these two formula because the subject GRE like to ask about this question. Okay, so 48 basic electronics. So there are three circuit, three notation you need to remember. Maybe not just three, but some basic you need to remember, and you can use them to derive some consequence. Okay, so basically, this is and this is or, and this dot is not. Okay, so we from here we have a. By the way, when we write it or, we write a plus b, and we write a dot b. Right, because in n you need to 1 plus 1, right? 1 times 1 need to only be. So you need to, if this has 1, then all of them must be 1. So we have not a. We have not a. So this is or. So we have not a plus not b. Right, and then we do the. And the result we do a negation. This is 1, and the second one is C, and it's not B, and we do end, and finally we get another end. So we times this. But there's no this answer. So we use the common called De Morgan rule. Maybe we, I don't know. We already have the answer. This is C. So nice. We don't need any additional law to solve it. The answer is C. So remember these two, right? We first do the AB OR, and not A and not B OR, and we do a negation, and we do a negation, and we do another end. So 49. Later utilize the involves energy level of the free atoms. Okay, so utilize the transitions. Basically, what's the answer? Free atoms. The answer is D, right? Because the gas, if you have a lot of gas, then you shine light. Then the transition from the transition from the you apply voltage, the transition from the free atoms will give you the light. So the answer is D. The only answer is D. Okay, 50. Which of the following expression is proper total proportional to the total energy and Bohr? And what's the answer? Usually the Bohr model, if you really forget, you need to solve it by you need to solve it from scratch, right? But usually we don't need to do this because we already know we only need to know the factor involved. So basically, all you have is KQQ divided by R squared is equals to, in this case is positive ZE, and so you have Z squared is MV squared over R, and RMV is NH bar. So usually we solve these two equations, and then we can get the VE, and then once we get the VE, then we know the total energy. The good thing is we don't have to solve it. We can so basically we can still solve it. Okay, so this one tells me that MV squared is equals to R over KZ squared, and then we have NH bar equals to RV. So one thing is that this is the total energy, right? So this tells you what? This tells you what? This tells you that this answer is, if you times the half to half, so you get this expression. So the only remaining constant we don't know is this R. So basically we can solve R when we plug. Okay, so basically we plug V equals to NH bar MR, and we have M NH bar N square H bar square M square R square equals to R over KZE square. And then this tells you that R is proportional to 1 over Z. So this tells you that E must proportional to Z squared. E must proportional to Z squared. So the only remaining answer is CDE. And the rest is just direct computation. From here we can solve our R is equals to we can solve R here. So the R is equals to something, but we know that it should proportional to N squared M E squared Z, right? Because you cancel these R. So R is proportional to this M cancelled, the M squared still here, and Z. So when we plug this one into this one, then we know that there should be another Z squared, and then there should be an M in the numerator. So it's mz squared e to the fourth. So the answer is C. Basically, this one just direct computation, nothing special. Okay, basically that's it, and I will see you guys in the next video.